Hello busy people, welcome to my channel Leetcode for you. Today we are going to solve daily Leetcode challenge, find missing observations. The problem states that you have observations of n plus m six-sided dice rolls with each face numbered from 1 to 6. N of the observations went missing and you only have the observations of m rolls. Fortunately, you have also calculated the average value of the n plus m rolls. You are given an integer array rolls of length m where rolls of I is the value of ith observation. You are also given the two integers mean and n. Return an array of length n containing the missing observations such that the average value of the n plus m rolls is exactly mean. If there are multiple valid answers, return any of them. If no such array exists, return an empty array. The average value of a set of k numbers is the sum of the numbers divisible by k. Note that mean is an integer, so the sum of the n plus m rolls should be divisible by n plus m. Here uh, they have given some examples. Example 1, they have given input roles array as 3 2 4 3, which is the of m length, and also given mean is equals to 4 and n is equals to 2, which is the n values missing array. We have to find that one. All the missing array values all strictly lies between 1 to 6 because they have already given it is a six-sided dice roll. And in second example they have given roles array and mean is equals to 3, n is equals to 4. We are going to analyze these examples diagrammatically. The problem states that n plus m six-sided dice. So let us take example 1. Roles is equals to 3 2 4 3 as an array, and mean is equals to 4 and n is equals to 2. As it is stated that it is six-sided dice, the total values of missing observations should lies between 1 to 6. And let us find the mean. We already know that sum of the observations by number of observations, so the sum of observations is the n plus m observations. So I have taken 3 plus 2 plus 4 plus 3 plus missing values as n1 and m2 by total number of lengths like n length and m length, 4 plus 2. Since mean value is given in the problem, now we can find the sum of missing observations n1 plus n2 is equals to 12. For that missing values, we have many combinations. Suppose let us take n1 is equals to 1 and n2 is equals to 11. N1 is equals to 2 and n2 is equals to 10. So that there may be many combinations, but strictly they have given the values of n1 and n2 should lies between 1 to 6. So we have to see that validation. For that combinations there may be 2 to 12. The sum may be lies between 2 to 12. Since the sum is 12, we can take it as an valid answer. Now we have to find the minimum combination sum for this problem. The minimum combination sum for this problem is 2, since we can place one in n1 and another one in n2. We'll get minimum combination sum as 2 and the maximum combination sum as 12, since we can fill n1 as 6 and n2 as 6. Further, we'll find average sum. Average sum of n1 plus n2 is equals to 6, so that we can fill that average value. It is the minimum value we can fill in that places, and we'll get remainder as 0. If the remainder is not 0, that is case 2. If average value is not exactly divisible, then let us take three missing values n1 n2 n3 and their sum is equals to 14. The minimum combination sum for three missing values is 3 and the maximum combination sum for three missing values is 18, and our sum lies between 3 and 18, so it is valid. Further will find average value of n1 n2 n3. It is 4, so we'll fill that average value in our three places, and we have remainder in this case like 14 modulo divisible by 3, get the remainder as 2. These remainder 2 can be split into the missing values as 1 plus 1 or 2 plus 0. If we split this remainder as 1 plus 1 to the missing values, we'll get the possible combination as 5 5 4. If we split this 2 between these missing values, we'll get as 6 4 4. Both cases are correct, both combinations are correct. Now finally we'll demonstrate example 3, which is impossible case. Here they have given mean is equals to 6 and 4 missing values. For that missing values, we'll get the sum as 38, and the maximum missing value sum is 24, but here it is 38, so it is impossible to get missing values, so we'll return empty array. This analysis part we got a clear cut idea how to solve this problem. Now we'll go and code the same in Java. First we have to initialize the resultant array with the length of missing value array as n, and we'll find the total sum, which is mean into m plus n, roles dot length plus n. Now we'll find the missing observation sum, I is equals to 0, I less than roles dot length I plus plus sum minus equals to roles. Now we'll find the average sum of missing values as sum divisible by n, and the remainder as sum modulo divisible by n, and we'll find the missing values equals to 0, I less than I plus plus result of I is equals to average, and we'll distribute the remainder between them. Result of I plus plus remainder minus minus. Finally we return the result array. Here we forgot to code the impossible case. If some value is less than n or some value is greater than 6 into maximum combination sum, then we have to return empty array. Now we try to run the code. It is successful. Then we try to submit the code. 98%.